Today's objective is triangles, angles, sides, and more. So here's a drawing of a square. Now you know a triangle is half of a square, and since a square has four 90-degree angles, there are 4 times 90, 360 degrees inside of a square. So here's our square, and remember the little corner that shows that it's this is a corner that shows that the two lines are perpendicular, so that means this is a 90-degree angle, and I've drawn a line and colored in half so you can see it's a triangle, okay? So, since a triangle is half of the square, it has 360 divided by 2, 180 degrees inside of the triangle. So that means the measurement of these three angles in every single triangle will add up to 180 degrees. All right. So here's another triangle. I said in this triangle, one angle is 46 degrees, and the other two angles are congruent. And you remember congruent is what we use to mean equals when we're doing geometry. So this shows you that they're congruent because it says x and x, okay? So find the measure of the other two angles. So what could we do? Well, you need to remember that the sum of the angles in every triangle will equal 180 degrees, and then you can set up an equation. The first angle plus the second angle plus the third angle, okay, first, second, third, is 180 degrees. Combine like terms. Always combine like terms before you start moving things from one side of the equation to the other, okay? It makes your life so much easier. Combine like terms. Subtract 46 from both sides, we get 2x equals 134, and now we have to find what x equals. So divide both sides by 2. Half of 13, well, 2 goes into the 6 times with 1 left over, and then 2 goes into 14 7 times, so it's 67 degrees. So each angle x is 67 degrees, not the 46, okay, doesn't mean that one. All right. And since all of these angles are less than 90 degrees, the triangle is acute. In order for a triangle, when you're naming it by the angles, in order for it to be acute, all of the angles must be acute. Here's another triangle. In this triangle, one angle is 90 degrees, and you know that because of the right angle perpendicular line measurement indicator. Find the other measures. So this one I'm telling you is the measure of x, and this angle is 2x, okay, different from what we had up here. But we add them the same. We say one angle plus the second angle plus the third angle, x, 90 plus x plus 2x is 180. Combine like terms. Subtract the 90 to isolate the variable. Divide by 3. X equals 30. You're not done, okay? You just know that this is 30. And then this is 2 times x, so 2x equals 60, because 2 times 30 is 60. So the angles in this one are 30, 60, and 90 degrees. And that's a little special triangle that you'll learn more about in, oh, that looks like a 6. You'll learn more about when you're in geometry. Okay, another way to do this is you know that if one of the angles is 90, the other two angles must add up to be 90, because 90 plus 90 is 180. So when you have a right triangle, you can do a little bit shorter work if you want to. So we've basically just taken off the 90 on this side and taken off the 90 on this side, and starting with the 3x equals 90 pretty much. But we get the same equation. 2x equals 60, so x equals 30. Okay, and you can do either one of these, but only for a right angle. All right, so let's, oh, and this is important, sorry. Since one of the angles is a right angle, a 90-degree angle, the triangle is a right triangle. So we're naming these, and to be an acute triangle, all three angles have to be acute, but to be a right triangle, only one has to be acute, only one angle. I'm sorry, only one angle has to be right. The other two will be acute, okay? So one for right, all three for acute. All right, here we go. In this triangle, we are given two angles and just need to find one angle measurement. Okay, I'm telling you this angle over here is 25 degrees, this angle over here is 15 degrees, and this angle is x. So 25 plus 15 plus x is 180. Once again, combine your like terms. This time they're the numbers as opposed to the x. 25 plus 15 is 40. Subtract 40 from both sides to isolate the x. X equals 140. So 140 degrees, really. And angles over 90 degrees and less than 180 degrees are called obtuse angles. Okay, I didn't define acute angles for you, but those are angles that are more than 0 and less than 90. And then the right is right at 90. Since this triangle has one obtuse angle, this angle right here, 140, it is an obtuse triangle. So once again, you only need one to be obtuse, you need one to be right, but you need all three to be acute. So if you are naming triangles, classifying means naming, by their angles, your three choices are acute, all three angles the same are acute, right, one is 90 degrees, or obtuse, one is greater than 90 and less than 180. All right. Now let's go through and look at some triangles and classify them by their side measures as opposed to their angle measures. So I've drawn several triangles here, A, B, C, D, E, and F. Okay. The tick marks on the side indicate if the side measurements are the same or different. So one tick mark, the little line is called the tick mark. One tick mark means they're all three the same measurement. Notice this one has 1, this one has 2, this one has 3. That means every single line is different. Okay? Here's 1, 1, and 2. So that means 2 are the same. These two are the same, but this one is different. Same with this one, 1, 1, and 2. Here's another 1, 2, and 3. So those are all different. And here's another 1, 1, and 2. Now I guess you could do 2, 2, and 3 and show that the two 2's are the same, but I don't want to draw more lines, right? So let's go through and say what each one of these would be. This triangle would be, oh wait, I didn't tell you this, classifying by the side measures. If all three are the same, it's equilateral, equal, and lateral means side. If two are the same, it's isosceles. I have no idea how they came up with that name, but you do need to know how to spell this correctly. I-S-O-S-C-E-L-E-S. Okay? Yeah, it's math, but you need to know how to spell. And if none are the same, it's scalene, which you also need to know how to spell, but it's not as hard. So what would this triangle be? Equilateral, scalene, and what type of triangle is this? This is a right triangle, right? So it's a scalene right. This is an equilateral, and it's also acute, and I'll talk about that in a second. What's this one? Equal. These two are equals. This is right isosceles, because two are the same. Thank you very much. This is isosceles also, but we don't know what this angle is up here. It looks like it could be obtuse, or maybe it's right. I don't know, because it's not, so all we know is that's isosceles. This one, though, it's scalene, and you can tell this is greater than 90, so this would be scalene and obtuse. And this is isosceles, and it's also acute. Notice equilateral, which can also be called equiangular triangles, are always also acute, because if the sides are equal, then the angles are also equal. So 180 degrees divided by 3, equilateral triangles always have 60-degree angles. Isosceles triangles can be right isosceles or not. It just says two sides are the same. And scalene triangles can also be right scalene or not. It just means no sides are the same. All right. You can also find angle measurements if I give you a ratio. So if I say the ratio of the angle measures is 1:3:5, that means the second angle is 3 times the first, and the third angle is 5 times the first. Okay, it's just all they did was leave off the x's, or I left off the x's. So you would write it like this: 1x plus 3x plus 5x is 180. And it's always 180 because every triangle's inside angle measures is 180. So combine our like terms, okay, and we get 9x equals 180, divide by 9, x equals 20. But remember, you're not just solving for x. That's not the end of the problem. You need to know that's this measure, but what's this measure and what's this measure? So 3 times 20 is 60 degrees, and 5 times 20 is 100 degrees. okay? So the three angles are 20, 60, and 100, so it's an obtuse triangle, and it's also scalene. And I know it's scalene because all of the angle measurements are different. So if you have two angle measures that are the same, that means two sides are the same. If you have all three the same, that means all three sides are the same. If you have none the same, it means none of the sides are the same. So the sides are different because all the angles are different. What if I give you a problem like this? I say this side is x, this side is 40 millimeters, this side is 2x, but I tell you what the perimeter is. I tell you the perimeter is 100 millimeters. You can find the side measurements when given the perimeter. Remember, the perimeter of a triangle, you just add up the three side measurements. The formula is perimeter equals side 1 plus side 2 plus side 3. And it's up to you to decide which side you want to be side 1. It's not like in doing the Pythagorean theorem where it's A, B, and C specifically. So I'm just going to fill in x, 2x, and 40 and add them up, combine like terms. 3x plus 40 equals 100. Subtract 40 from both sides, isolate the variable, divide by 3, x equals 20, and 2 times x equals 60. Okay? And once again, I'm telling you, always combine your like terms before you add or subtract. People have been making a lot of mistakes in that. I don't want you to do that, okay? So let's check. So if I have 20 plus 60 plus 40, does that add up to 100? No. What did I do wrong? Oh, because what's 2x? 2x isn't 60. Silly. Silly me. 2x equals 40. Haha. Okay, the side measures are 20, 40, and 40. And so what type of triangle is this? I have to erase this. I made a mistake when I wrote this. You should say it's isosceles. Because two sides are the same. Don't you like it when I make a mistake in those? All right, and that's it.